All right, so let's do this last example. So it says, suppose that C of x equals 0.2x squared plus 2x plus 4,000 is the total cost in dollars for a company to produce X units of a certain product. So it says compute the marginal cost at 100 and compare this to the actual cost of producing the 100th unit. So these are kind of strange questions. So if you're finding the marginal cost, we know that we're going to take the derivative. So our derivative of 0.02x squared is going to be 0.04x, and then we're going to have plus 2. And then we quickly plug in 100. So I have 0.04 times 100 plus 2. So we get 6. So what does that mean? It means around when you're producing the 100th item, then your cost per item ends up being around $6 per unit. Okay? So you would want to sell it for more than $6. All right, so the actual cost of producing the 100th unit, that's a little bit strange. Anybody have any ideas on the actual cost of producing the 100th? It has to do with the total cost equation, like the C of x equation. Most people think that you just plug in 100. Okay, but that's the total cost of producing 0 through 100 units. So what about the 99? It involves 99, so it's actually going to be C of 100 minus C of 99. So you're going to find one of them, and then you're going to subtract out the 99 one. So I am going to go ahead and put these in for my table so I can find them quickly. I love the table function, if you guys didn't notice. Find lots of points all at once. So the cost of producing 100 items is $4,400, and the cost of producing 99 items is $4,394.02. So we end up getting $5.98. Okay. So which one was faster and easier to do by hand? The first one, right? So that's why we use our marginal cost. It's just faster. Okay. So you can do spreadsheets and so on to find the actual cost of reducing the 100th unit, but it's just faster to use something that's 1 degree less. Okay, derivative's always 1 degree less. So, all right. So find the production level that minimizes the average cost. So it says, what does the minimum of a graph look like? How is that related to slope? So the minimum of any graph, what's happening right here? What's the slope? It's 0, right? So we're going to find our average cost, and then we're going to find its derivative and set it equal to 0. So there's a lot going on here. So the average cost is our C bar. So we're going to take our total cost, and we're going to divide by x. Right, that's what C bar was, divide by the total number. So we get 0.02x plus 2 plus 4,000 over x, which I'm going to write as 4,000x to the negative 1, because I want to take the derivative of it quickly. So C bar prime, isn't it fun saying all these math things? C bar prime is going to be 0.02 minus 4,000 x to the negative 2. And we said we wanted when our slope is equal to 0. So we're going to set that equal to 0. So now I'm going to rewrite it as 4,000 over x squared. So I have 0.02 minus 4,000 over x squared. So I'm going to add the 4,000 over x squared over. I'm going to divide or multiply the x squared over, so 0.02 x squared. And then divide by 0.02. So 4,000 divided by 0.02, and then take the square root of my answer, and I get x equals 447.216. So what is the level that minimizes the average cost? We want to minimize our cost function or average cost, so we want how many units? Yeah? 0 units. Is it smaller? I don't know. So it's going to be, we think that it's going to be 447 units. Now, Grant does bring up a point. He said it's 0, right? You don't have a cost if you don't produce any units. Well, what if you own a factory? And what if you hire all these people to come into work that day? And then you have this big machine that you paid money for, and then you produce 0 items. That would not be good, right?
Is it worth that going?
Yeah, when people go on strike and so on, that's not good. So really, we should eventually, and we'll talk about this when we talk about maximum versus minimum. We'll compare these different things. So you could try like, well, what happens when I plug in 500 units to here versus plugging in like 0 units? You kind of want to try things on both sides. So you would try like 500 and you try 0 and then see which one gives you. 0 wouldn't work actually because it's undefined there, but you could try like 1. And then you would want to make sure that that is the minimum amount. And I think it is.
So when it ever says minimize the average cost, which basically means equals 0.
Yeah, but that's also what you would do for maximize the average cost. So you really would kind of have to compare. So if I plugged in 0 into my C bar function, or not 0, let's say I plug in 1, I get 0.02 plus 2 plus 4,000 times 1 to the negative 1 is 1. So I'd get $4,002 and $4,002 and 2 cents, like that. And then if I plug in like 500, let's say 0.02 times 500 plus 2 plus 4,000 times 500 to the negative 1. So you get 20. And then if you plug in 447, what was that, 20? Yeah. What's up?
Not sure.
And then this one's 1989. So creating no items, or in that case, one item that we did, cost you like $4,000, right? So that's not good because you've already paid money for this for various things in the factory or whatever. And if you create 500 items, you're at like $20. But this is kind of the sweet spot. You want it to be as small as possible per item. Okay. Does it make sense? You get it? Alrighty.